any sum of money. You could give her a 50. You take someone who's in school trying to get an MBA and say, would you be willing to take a risk where with 50% probability you give me $1,000 out of your student aid package for this semester, and with 50% probability I will give you like $1 gajillion. And they would say, no, I just can't do it. Because what we're talking about here is that it would mean that their little u just is like, just goes off to nothing. Sorry, not negative. It's so curvy that increases beyond sort of like, maybe this is where they are and this is where they think about getting in their first job, and anything beyond that just gives them no additional utility whatsoever. Right? To explain risk aversion in a small neighborhood around here where it's 550 one way or the other assumes so much risk aversion over lifetime wealth as to be completely implausible. And then he goes on, if they would turn down a slightly scaled up version, actually not exactly scaled up, but lose 1,000, gain 1,050, then they would turn down 50-50 bets of losing 20,000 or gaining any sum. Okay, so I guess the first one's actually a little bit more gee whiz than the second one. And then he just simply says these are implausible degrees of risk aversion. Right? So we've seen this implausibility argument before. And in this case, it's pretty compelling. It's pretty compelling that that's just implausible. It's not a scientific proof that the theory doesn't work, but it's pretty darn compelling. Indeed, way back in 1971, one of the great gurus of standard economics, who did win a Nobel Prize, I think. Didn't Arrow and DeBrew win the Nobel Prize together, I think? Down at Stanford, we'll forgive him for that, proved a very similar result, which is that no matter how risk averse you are, so let somebody be this risk averse, fine. No matter how risk averse you are, if I take a better than fair gamble that you reject, I can scale it down. And if I keep scaling it down small enough, eventually I'll come up with something that you'll accept, right? Because I scale it down, I get you into a narrow and narrow range where this thing starts to look linear. So for example, what Arrow demonstrated was, suppose that you reject, suppose that from what it does, your wealth level doesn't matter here. Suppose that you happen to be someone who rejects a gamble that's -500 with probability 0.5 and +550 with probability 0.5. What Arrow proved is that under expected utility, where you have this non-reference dependent utility function, I can find, there will exist, right? Backwards capital E means there will exist some epsilon greater than 0, some tiny, tiny little scale factor, let's say probably less than 1, such that if I scale these things down by epsilon, if I give you negative epsilon times 500 with probability 0.5 and positive epsilon times 550 with probability 0.5, right? So I just take the same exact relative proportions and just scale them down to something really tiny, I will eventually come up with something that you will accept. Okay? Because I will get you from, say, a gamble that takes you over a large range to a gamble that gets you closer and closer to being just right in a very, very tiny range of the utility curve where it will be effectively flat. And eventually, you will wind up behaving in a risk-neutral manner, and you will take the gamble. Okay? Unless, sorry, go ahead. Sorry, cliffhanger. Well, they're not hypothetical. This is like very similar to what 71% of these multimillionaires rejected. No, it's not. I'm sorry. Yes, it's hypothetical, but it's not sort of like sky-high crazy hypothetical. It's so economists deal with two kinds of facts: actual facts and what we refer to as stylized facts. Okay, the stylized facts are people reject gambles like this at any wealth level. Now, nobody's actually done that gamble, right? Barbarous, they didn't do it. They did it for people with a wealth of 10 million. They didn't do it for Bill Gates and Warren Buffett. But the stylized facts are people at all wealth levels turn down those gambles. But nonetheless, I'll grant to you that it is in some basic sense it's hypothetical. Yes. And so you're saying you were saying you don't understand how the fact that hypothetical scenario is implausible, how it creates an anomaly. The math of expected utility theory, which relies upon this concave little u, and we don't know what concavity it might have. What Matt Rabin proved was that for it to have enough concavity for people of any wealth level to reject that bet, it must have so much enough concavity to explain that is so much concavity that it would also predict that they would turn down insanely beneficial bets that we just know nobody would turn down. If you turn down a bet where with 50% probability you lose $1,000 and with 50% probability you get $10 billion, you are nuts, because you could get the 1,000 out of people's wallets right here and just promise to pay them back. Right? I would cheerfully give you $1,000, without even needing to be returned for you to take that bet, just because I like you from office hours and you're a good guy and I want you to have these kinds of opportunities. It's insane to think that anybody, even someone with literally no money, you'd go and get it. You would go and get that money. You'd say, give me half an hour. I'll knock over a liquor store, whatever it takes to get that money. Right? It just doesn't. It's just implausible. Okay. Are there any other questions before we move on? Okay. As we scale down the bet, according to Arrow, 1971, which is unfortunately also a book and therefore not on DSpace, as we scale down, no matter how curvy that curve is, eventually it's going to start looking like a straight line, unless there's a kink. Unless there's a kink in it. And by the way, not just any kink. It's got to be a kink that stays in that narrow range no matter how much we zoom in on it. Well, we've seen such a kink. Okay? Here's a reference-dependent utility function. It's got a kink. And interestingly enough, that kink is always at your reference point. So if your reference point, let's say, is your status quo current wealth, right, at the time that Barbarous, Hwang, and Thaler ask you whether or not you want to take this gamble, if we just let the R equal your current wealth W, then no matter how small we make that bet, that kink's still going to smack in the middle of it. Ta-da! Right? Well, that's helpful, because that means that even if the how you feel about gains and about losses is linear, if I say this axis is x minus r, so here's x minus r of -500, lose 500, and here's x minus r is positive 550. If I take how you feel about that, right, and how you feel about that, and I draw that little line segment, that little locus of expected utilities, it's always going to be, that line segment is always going to be below your value function because of the kink. The kink is effectively a form of concavity, but it's concavity that follows you around. Right? It's like this kid's book I had growing up about this kid called Wet Albert, who had a rain cloud that was always over him, right? And he wound up getting a little helicopter and saving drought-stricken regions from famine. That kink just follows you around like Wet Albert with his cloud. If you wind up with a wealth level of $10 million, as long as you adapt to that and it becomes your reference point, you're under the kink. You're there at the kink. Okay. Again, this is not a scientific argument. right? But it is pretty compelling. And there are plenty of more scientific arguments that I'm not going to get into to suggest that that's what's going on. Okay? So the instantaneous utility function, if people reject these tiny bets at all wealth levels, then there must be a kink in the instantaneous utility function. Arrow proved that. And the kink must be reference dependent because this thing follows you around. We've already seen that. People at different wealth levels have the same effect. Now, I'm saying that's not a scientific proof, and it's not, but it is nonetheless very good news for the science of behavioral economics. Because we've demonstrated pretty conclusively that little u is kinked at the reference point when there's no uncertainty. And if we're then going to build a model where we cobble together a bunch of little u's over different states of the world with a probability weighting function, it better be the case that that little u still has a kink in it, or we're really not doing science. Okay? So we're going to take this instantaneous utility function that we studied over the last 2 weeks, and we're going to import it, as we have done thus already, into an uncertainty framework, and then later we're going to import it into an intertemporal multi-time period model, and it better be the same instantaneous utility function every time, or we're really not doing science. So it's a thumbs up that we find the same kink when we look at uncertain situations. Okay. Next anomaly. We're still talking about the instantaneous utility function. This is my second instantaneous utility anomaly. It's called the reflection effect. By the way, the thing I just talked about is not in the Kahneman and Tversky paper that's assigned. Everything else from here on out is. So Kahneman and Tversky subjects appear to be risk-averse in the domain of gains. I offer you a risky situation where all of the outcomes are 0 or positive. People seem to exhibit risk aversion in most cases. So for example, would you rather have an 80% chance of getting $4,000 or definite $3,000? These things in square brackets are the number of people who said yes or no, and these ones are out of 100. So 80 people like the sure thing here. Well, what about 4,000 with a 20% chance or 3,000 with a 25% chance? It turns out this is the one with the lower expected value, and people like the one with the lower expected value because they're risk averse. So in all of these examples, risk aversion, people prefer the gamble with the lower expected value. Wait, we're not supposed to be looking at problem 8. Sorry. In all of these ones, people prefer the gamble with the lower expected value. That makes them risk averse, and these things are all in the domain of gains. All of the x's are positive, right? 4,000, 3,000, 6,000. Okay, and they appear to be risk-seeking in the domain of losses. Okay, so each of these problems, and again we'll ignore this last one. Each of these problems is just exactly the same as its counterpart over here, except that the x's are now negative instead of positive. And what you find is that now people prefer the one that's more risky. Yeah. My simple answer is that it has lower expected value. Is that right? Point 2. So it has an expected value of 800, and the other one has an expected value of 750. Okay, this is going to be one of those cases where I just can't. I'm operating now with an effective IQ of about 65, so I'm not going to be able to answer your question, but I will give you an answer and tell you. What's more relevant here is simply the fact that reference is flipped when you put a negative sign on it. Okay. We're coming back to that, but that's a probability weighting anomaly, not an instantaneous utility anomaly. Yeah, that's the one I deleted. This table covers more ground than I'm covering in this slide. Well, the main thing we're looking at here is that when you multiply all the x's by -1, the preferences flip. And in general, what they find is that people are risk-averse over gains and risk-seeking over losses. Okay. Now, what if it's the case that people are just, like the people when you offer them a gamble that involves gains, their expected wealth has just gone up, right? So they're richer, and maybe as they get richer, they just become more risk-averse. Maybe this risk aversion varies with income. So Kahneman and Tversky tried it a different way that, as we've seen before, clever ways to eliminate income effects. Okay. They said, the first question is, in addition to whatever you own, you've been given $1,000. Now you're asked to choose between receiving 500 for sure or 1,000 with probability 0.5. And then over here they said, in addition to whatever you own, you've just been given 2,000. Now you're asked to choose between losing 500 for sure or 1,000 with probability 0.5. And those two things are both asking you how you feel about the gamble that is W plus 2,000 with probability 0.5 or W plus 1,500 with probability 0.5. So there can't be any income effect going on here because they're both being offered exactly the same gamble, but one of them is framing as a gain, one of them is framing as a loss relative to if you include the money you've just been given into your reference point. Yeah. And it didn't change the results. Okay. What does this suggest about the shape of the value function? Okay. If risk preferences over gains or over losses are affected by the curvature of the value function, right? We've already seen this value function many times where it goes up, with kinked and has a different slope in gains or losses. If people are risk-seeking in the domain of losses, then that must mean that their value function is convex up in the domain of losses. And if they're risk-averse in the domain of gains, it must mean that their value function is convex down in the realm of gains. Okay? So that if I draw these little locuses of expected utility, for gains, the expected utility is below the certainty equivalent, and for losses, it's above. Okay? So you'd be risk-seeking in one case and risk-averse in the other. It's still got a kink, right? It's still got a kink right there at the origin. So now we've incorporated a new psychological feature into this instantaneous utility function. Now, you might ask, as Friedman and Savage did back in 1948, which we saw in the first day of the class, why can't this just be explained by a wiggly utility? Remember Milton Friedman sort of poking fun at himself and saying, why can't I just have a wiggly little u? Why can't I just say, hey, if this is your current wealth level, well, maybe you have a little u that looks like that, so that you're risk-seeking over losses and risk-averse over gains. But we already have a lot of reasons why we can just reject that out of hand. First of all, that's actually exactly the opposite of what Friedman and Savage actually tried to explain. But leaving that aside, we already know that it can't be based on that because of the way Kahneman and Tversky reframe things to eliminate income effects. We know that people's preferences are affected not with no respect to whether it's actually a gain or loss, only with respect to whether it's a gain or loss relative to their reference point. So that immediately rules out some kind of wiggly little u argument. Also, we already know that the instantaneous utility function is reference dependent. We know this. Now we're just talking about its curvature. Okay? Also, there's this thing that we've sort of pointed to in a couple different areas. This reflection effect that your risk aversion switches to risk seeking when the sign of the outcomes changes is true for people at many different wealth levels. So it's just kind of implausible that everybody happens to have a wiggly little u that's wiggly that has an inflection point right at their current wealth. This just seems implausible. Okay? What we think is actually going on is this phenomenon that psychologists and many others have observed in basically every possible domain of human perception. Right? Remember in the second lecture I went through various different domains of perception and said that there's reference dependence? There's also this phenomenon called diminishing sensitivity. Okay? In how we perceive distance, the difference between 0 feet and 1 foot is perceived as greater than the difference between 100 feet and 101. Okay? With respect to time, the difference between today and tomorrow is different. It feels much bigger than the difference between 100 days from now and 101 days from now. Okay? With probability, as we're going to see next time, going from 0 to 1%, we perceive that as a much bigger difference than say from 42% to 43%. And it turns out that that's not just true for humans; it's true for all sentient organisms. I'm not quite done. Is that true? That is not true. I actually am done. Are there any questions in our 30 seconds remaining? Okay, so we'll pick up with with probability weighting anomalies on Thursday, and then I'll show you some applications of prospect theory in the real world.